Hi guys, in this video we're going to have a look at scatter graphs. So what is a scatter graph? Well, a scatter graph is a way to show if there's a relationship between two sets of data. So for example, I've got my first one here. So I've got shoe size and height, and as you can see I've randomly plotted some points here. And I've got temperature and cinema tickets, and I've got some points here, and I've got birthday and annual income, so basically your salary. So they're like two sets of data, and then you can compare them or plot the results to see if there is a relationship. So if we go back to our examples here, we can have a look and see if there is. Now when you have all the points increasing like this one here, so as the height increases and the shoe size increases, we can see we get this sort of pattern here. This shows there is a relationship. As one increases, so does the other. And we say that that's got a positive because they're both increasing. One increases, so does the other. So it's positive correlation. I've deliberately made this word nice and big here, correlation, because that is the word to take away when you think about scatter graphs, correlation. So we say this has a positive correlation. Okay, you must remember that word there. This one here, so we've got cinema tickets and we've got temperature. This one's slightly different. There is still a relationship because as the temperature increases, cinema ticket sales decrease. So as one increases, the other decreases. So we say this has a negative correlation. So as one increases, the other decrease. So positive is easy, they both increase. This one here, as one increases, the other decreases. So that's negative. And then we've got this one here where we compare two sets of data. So we've got birthday and annual income, and there's just no pattern whatsoever. Nothing's increasing or decreasing. It's completely random. So in that case, we say there's no correlation. But in every single instance, we use that word correlation. Okay. Now you can get a little bit keen and you can have different types of positive correlation and different types of negative correlation. So here we have three cases of positive correlation. All of these are increasing. Okay, going up like that, absolutely fine. But because these are much more closer together, we say this has a stronger relationship because it's really defined. All the points are really close together. It's a strong relationship. This one here is still positive. All three are positive. This one's still positive, but it's not as strong as this one. The points are slightly more distance apart, but it definitely is still positive. So we say it's got a moderate positive correlation. And this one here, the points are again more spread out, but still going in a positive correlation, still increase, both are increasing. So we say that would be a weak positive correlation. And exactly the same thing down here with the negative. This one here you can see is a strong negative correlation, and then a moderate negative correlation, and then a weak negative correlation. You don't necessarily have to use these words, but it's just worth noting that that is a strong, moderate, weak, as the points get more and more spread out. So that's the basics. Let's have a look at the line of best fit. So word takeaway from this one, correlation. And then the line of best fit is definitely what you need to take away from this one. And you will always have to do this with a scatter graph. If you don't, you will lose marks. So what is a line of best fit? Well, quite simply, it is the line that fits best. So here I have a positive correlation, in which case my line of best fit will be going in that direction, in a positive correlation. And the idea of the line of best fit is to try and get the same number of points above the line and the same number of points below the line. Essentially, you want to try and go straight through the middle of all those points. And you will have a little bit of leeway with this in the exam, so you don't have to be bang on the money, but you can't be like over here, for example. You have to sort of try and get it. And use a pencil. I mean, I'm using a pen, but use a pencil in case you do get it slightly wrong. So 1, 2, 3, 4, 5, 6, and that point there is 7. So if I go about there, 1, 2, 3, 4, 5, 6, 7, 8. So I probably just want to come just a little bit more down, something like that. Okay, so I've gone somewhere like that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. But I've gone a little bit closer to this one. In the exam, they'll have the exam marker will have 2 lines like that. And as long as your line of best fit is in between those lines, you'll be absolutely fine. You'll get the marks. Key point, I said try and get half above and half below. That doesn't mean you go this way and get half of them this side and half on this side. As I said before, if it's a positive correlation, your line of best fit must be going in that increasing direction. Same with this one. This one is a negative, so my line of best fit will be going down that way, not that way and getting half and half. It must still be a negative correlation. And let's have a look. I've got 1, 2, 3, 4, 5, 6 there. 1, 2, 3, 4, 5, 6. So actually that one might be a bit easier. So there's 6 there. Yeah, to go down something like that. And again, if you've done it in pencil and you're not quite happy, just rub it out and you might want to tweak it. So for example, this one here, I might just want to tweak that slightly that way a little bit. Obviously I can't because I've done it in pen, so use a pencil and you can get it just right. But as long as you are within the guidance of the exam mark scheme, you will get the marks. Okay, so that's the line of best fit. So along with correlation and the line of best fit, you need to remember those when you're dealing with scatter graphs. Okay, so let's put it all together and start answering some common questions. So first one here we go. So the scatter graph below shows the height and weight of 7 people. Now sometimes they'll just give you the scatter graph complete. Sometimes they'll do what they've done in this bit here, where you have to plot some points. Okay, so let's have a look. I've got my height here and I've got my weight down here. So if I'm going to plot these points, I've got 100 and the height is 190. So I'm going to plot that point there, just check it, 100 and 190, yep. And I've got 95, which is there for the weight, and 195, which is there, yep. And then 105 and 155, which looks odd, and I'll come to that in a minute. Okay, so that's usually what will be the starting point. The second question will probably be something like this. What type of correlation does the graph show? There's that word correlation. And all you need to do here is say positive, negative, or no correlation. And as we can see here, these points here are increasing. So that would be a positive correlation. If they haven't used the word correlation, in fact, even if they have used it, always say positive and then add the word correlation. Of course, if it's negative, you say negative correlation. Sometimes they use it, sometimes they don't, but just get in the habit of always saying positive correlation, negative correlation, and then you should get the mark for that one. Question 3 then. The weight of a person is 80 kilograms. Estimate, so have a guess, but a good guess, at the height of the person. Now, what I see all the time when marking papers is that people go 80, they'll go up to that person there and go, oh, okay, and then go across like that. No. That isn't how you do it. Okay, like I said in the previous slide there, you must use the line of best fit. So let's have a look. I've got 1, 2, 3, 4, 5, 6, 1, 2, 3. So it's probably going to be something a bit like that. Again, use pencil just in case you get this wrong, so I'm sort of doing it like that. Yep, that'll do. Okay, so you must draw a line of best fit. And then it says the weight of a person is 80 kilograms. And again, get your ruler. And from 80, and draw the line, don't just use it and guess, draw the line from 80 up to your line of best fit, and then go horizontal across to the height. Okay, and I'm going to guess that is 181. Okay, it might be 182, but I'm going to go with 181 centimeters. Okay, so you must use your line of best fit. Whenever you're estimating, you must draw a line of best fit and draw those lines there to prove your estimate is, well, an estimate. Okay, don't just guess it by having a look. Draw your line of best fit. And if you draw a line of best fit, it might be slightly different to your friends when you get out of the exam. It might be slightly different to the examiner because you've got that little bit of leeway with how you can draw your line of best fit. However, as long as you do your lines up here and across, to show you know how to do it, you will get the marks. And I've added this question down here. Which value is an anomaly? It might be also called an outlier, or anything like that, but usually we use outlier or anomaly, and that just means which one is out of place, which one isn't conforming to the rest of the data. And I said I'd come back to it. It's clearly that one there. That one is a bit of an anomaly. It's out in the middle of nowhere on its own, doesn't fit all these ones, so we would say that's the anomaly. So which value is an anomaly? We would say we'll go the 105 kilograms for the weight, and you could probably put the weight there as well. And then obviously the height, we'll just put those height values, which was 155, and that's centimetres. So they don't always ask the anomaly question, but it's always worth knowing what that means. Okay, so that's one example, and on to the last one here. It's not too much to worry about with scatter graphs, so here we go. So this one here, no plotting, it's already done, and we're told the scatter graph below shows number of cinema tickets sold and the temperature. So as we can see here, our points, so ticket sales are decreasing as the temperature is increasing. So it says describe the relationship between the temperature and the tickets. It doesn't say what type of correlation, it says describe the relationship. So we need to do a little bit more detail here, and it's exactly what I just said. So as temperature increases, so as the temperature increases, ticket sales decrease. And then you can put your negative. We say therefore a negative correlation. Okay, so you have to do a little bit more detail there. You can't just go negative correlation, although that is correct. When it says describe the relationship, just go a little bit more detail. As temperature increases, ticket sales decrease, and then you add your negative correlation. Okay, question 2 then. If the temperature was 14 degrees, estimate the number of ticket sales. Again, we're going to draw our line of best fit here. And again, you should use pencil. I'm going to go with that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's gone through that one. Yeah, you may want to just tweak that, but that would be absolutely fine in the exam. So 14 degrees is the temperature. So again, I'm going to draw my line up from 14 to hit my line of best fit. I'm going to then go across to show the examiner I know what I'm doing. And that's roughly about 3/4, so I'm going to say that's 375 ticket sales. And again, yours might be slightly different. The examiner will have a range. As long as your number is in the range, you'll be absolutely fine. And especially if you show exactly how you did it, you'll be absolutely fine, which is why it's crucial to draw that. And then finally, this one here, they love to put this on at the end of questions these days. Explain why it may not be appropriate to use the line of best fit to estimate the number of ticket sales if the temperature was 30 degrees. So 30 degrees obviously be over here. So why would it be inappropriate? Well, starters, it probably will go into negative ticket sales, which obviously will be irrelevant. But the main reason, or the way to answer this, is when you have a question like this where it's 30 degrees and you have no data. We have data between 18 and 2 degrees. That's what we have data for. If you're asked a question, if it's over here, whether it be ticket sales in the 2,000, 3,000, 4,000, or temperature over here, which is even bigger, so basically you have no data, there's no way that you can draw any estimates or any conclusions because you just have no data to support it. So when we're answering this question, we'll say we have no data past 18 degrees, therefore we can't make any correct, maybe. Let's use the word correct. Correct estimates for 30 degrees. Okay, so something along those lines, just basically saying we have no data past 18 degrees, so we can't make any conclusions about 30 degrees, or basically the point that they want is outside of the data range that we have. Something along those lines will get you the mark. So that's scatter graphs, guys. Nice and easy. If you remember positive, negative correlation, you remember to draw your line of best fit, and you definitely remember to use a pencil and a ruler in case you make a mistake. Thanks for watching, guys. Cheers.